Hey everyone, Mr. Geiselman here to go through our lecture for today. Today we're going to be really focusing on velocity and especially calculating velocity. So that's where we're going to get headed today, right? So hopefully you took your test over the last couple days and you're ready to rock and roll into our next unit. So the first thing we kind of need to talk about is what is motion, and that's what we're getting into in our next unit. So, motion is defined by a change in position measured by distance and time. So, what motion really is a change in your position. So, you go from point A to point B, right? And we measure how far you went in your distance and how long it took you to go that far, right? And anytime you think of motion, you can think of movement. So if there is no motion, whatever that object is did not move. If you did move, all right, there was some motion involved. And commonly we use the units meters per second, but we also use things like miles per hour, kilometers per hour, and different things like that. That's really what we get into with motion, right? So think about it, you're riding your bike, you're moving a certain distance in a certain amount of time. So distance over time is going to be equal to our motion. And that brings us into our first piece, which is speed. So I think we all know this, but speed is the distance traveled by an object in a given amount of time. So the greater your speed, the more distance traveled in a shorter amount of time. So you can think of it as a rate of change in position over time. So we're changing our position, all right, our distance from a certain object over time. And it's really how fast we're moving. Probably guessed it already. Our units for speed are meters per second, but we can also use miles per hour, kilometers per hour, and all sorts of different distance over time increments. Our equation for speed is equal to distance divided by time. So it's a really simple equation. It's a lot like volume is equal to mass over, or sorry, density is equal to mass over volume. It's the same kind of idea that speed is equal to distance over time, right? And again, speed is equal to speed equals distance divided by time. So let's do a practice problem with speed. James was driving down the highway and made it 45 kilometers in 0.5 hours. What was his speed in kilometers per hour? And then as a bonus, what was his speed in meters per second? So the first thing we're going to want to do is we're going to want to identify our variables. We have, let's start with picking out our equation, and we already know that speed equals distance over time. So let's see which ones we have. What variables do we already have? We have 45 kilometers, right? That is going to be our distance, right? 45 kilometers is equal to distance for us. And we have zero point 0.5 hours. That's going to equal our, not our speed, excuse me, our time. 0 0.5 hours equals our time. So now we can go in and we can substitute those. So if we take our equation, speed equals distance over time, we can get speed is equal to our distance of 45 kilometers. And it's really important that we put the kilometers because that's part of our answer, divided by 0.5 hours. When we did our first unit, we looked at canceling a lot. Now our units there don't cancel, so both kilometers divided by hours are going to be in our answer. And if you punch that into a calculator, 45 divided by 0.5 is equal to 90. And then we take our kilometers over our hours. All right. So that's the first part, right? We found our speed in kilometers per hours, or kilometers per hour. Now we're going to try this again, but we want to find it in something different. We want to find his speed in meters per second. Well, all we need to do for that is we need to do a little bit of converting. So I'm going to erase a little bit of that. We know his speed in miles per hour. Now let's find it in meters per second. to do that, we need to convert 45 kilometers into meters. And 45 kilometers into meters, we know that kilometers are bigger, right? So our number is going to get bigger as we go to meters. And we know that kilometers are 3 spaces down in our metric system, or that there's 1,000 meters in every kilometer. So we're going to multiply this number by 1,000 or add 3 zeros to the end of it. And we're going to get an answer of 45,000 meters. All right, so that's how far he went in meters. So our new distance is 45,000 meters. I'm just going to put D equals 45,000 meters right up here. And now we need to do our time. Well, we know that we start with 0.5 hours. And we know that in every hour, there is 60 minutes. And we know that in every minute, there are 60 seconds. We're able to cancel our units using dimensional analysis, and we're left with seconds, which is the unit we want at the end. So we take all the things on top, we multiply them together, and we divide by the things on bottom. So 60 times 60 times 0.5, and our unit's going to be in seconds. That is equal to 1,800. I'm going to change back to red. 1,800 seconds divided by, on the bottom, 1 times 1, because our units have been canceled out. 1. So 1,800 seconds divided by 1 gives us a time of 1,800 seconds. And now we're set up to solve this problem. And now we can just go back in to the original equation that we used. Speed is equal to distance over time, and plug in our new numbers, and we can find our new answer in meters per second. So we have speed is equal to our distance of 45,000 meters over our time of 1,800 seconds. And when you take 45,000 divided by 1,800, you get an answer of 25 meters, right? Because meters don't cancel out, and seconds. So we know speed now is equal to distance over time. What's the difference between speed and velocity? Well, the difference between speed and velocity is that it's still your speed in a given direction, but the key piece here is that it has direction as a part of it. So velocity is still a rate of change in your position, but we include what direction we are going in. So our standard units are still going to be meters per second, but now we're also going to have to add the direction. So our equation for velocity is velocity equals distance over time, just like speed, with the added direction, right? So everything remains the same, but now we're adding in direction to our answers. Another way of thinking about this, when we look at an answer, velocity could equal something like 10 meters per second to the left, or it could equal something like 10 or 5 meters or miles per hour, south. So it's still going to be a speed unit, those standard units for speed, like miles per hour, kilometers per hour, or meters per second. And again, our standard is that meters per second. And it's going to now include the direction. And that's what sets a velocity apart from speed. So let's do some practice problems. Mr. Oleg rides his bike 3,000 meters south to school. It takes him around 2,000 seconds to make the trip. What is his velocity? Well, let's figure out. We have 3,000 meters and we have 2,000 seconds, right? If we have an equation of velocity equals distance over time, we know that our distance here is 3,000 meters and our time is 2,000 seconds. So now we can sub those in. And yes, I know we are forgetting right away. We're forgetting to put in south. So we'll save that for the very end because that is our direction. So let's sub in our numbers. Velocity equals 3,000 meters divided by our time of 2,000 seconds. Because meters and seconds don't cancel, meters and seconds will both be in our answer. And when you take 3,000 divided by 2,000, you get an answer of 1.5. We take our units in, meters per second, and then we add in that direction, south. Okay, so first thing, what equation should we use? Sorry that it gets a little messy here. So what equation should we use? Speed equals distance over time, or velocity, excuse me, equals distance over time plus direction. Right? There's the equation that we use. We subbed in our variables, right? V equals 3,000 meters divided by 2,000 seconds to the south. And then we solve finally, and I believe it's covering up my answer there. But velocity equals 1.5 meters per second south. So our next problem, what if we had the speed or the velocity already, but we didn't have something like distance? So calculate the distance if you traveled for 5 hours on a bike at 12 kilometers per hour south. Now we can just rearrange the equation. So we use that same equation, velocity equals distance over time plus a direction. We know the time, we know the velocity. Now we need to figure out what our distance is. Right? All we'd have to do is we'd have to sub in our numbers, and then we would have to do a little bit of algebra, right, to get that unknown variable, in this case, distance, all by itself. To do that, we'd multiply both sides by time. So d equals velocity times time. So we'd multiply both sides by 5 hours, right? Distance equals 12 times 5. And because it's kilometers per hour times hours, those hours cancel out and we're left with the unit of kilometers, and that's our answer of 60 kilometers. Our last problem here is Mary is training for a race. She runs a loop that is 2.5 kilometers each way for a total of 5 kilometers. She runs the south path in 10 minutes and the north path in 12 minutes. Determine her velocity on the south path, the north path, and the total speed in meters per second for her run. Right? So we're going to find 2 different velocities, one for the north path, one for the south path, and then one for her total speed in the whole thing. So let's start with the south path. Right? The steps, we're going to determine the variables. What are her variables? We know that our distance is 2.5 kilometers. So that's distance. And on the south path, she's running it in 10 minutes. That's our time. And again, south will be our direction. So let's substitute then. Velocity equals distance over time plus the direction. All right, so now we can substitute velocity equals 2.5. Oh, we have 10 minutes. That's not going to work for meters per second. So what do we need to do? We need to do a little bit of conversion. So let's do that conversion over to the side. There are 10 minutes. There are That should be a minutes, not a miles. Sorry about that. So we have 10 minutes, and we know that in every minute there are 60 seconds. We can now cancel out our minutes, and we get 10 times 60 divided by 1, and that answer is going to be in seconds. So we get an answer of 600 seconds. So we can substitute 600 in here, and that's going to be in seconds. Our top one is going to be in kilometers. Oh no, we need to figure that out too. So let's back that up. We know that there's 1,000 meters in every kilometer. So I'm going to multiply 2.5 times 1,000 to get 2,500 meters plus my direction south. Then I can do that. I can just plug that into a calculator and I can get my answer. So 2,500 divided by 600 gives me a velocity of 4.16 meters per second south. All right, so that's my answer for the first part. I got her velocity going south. So now I can substitute in and find my velocity going north. So now for my velocity going north, all I had to do was I had to change my time and my direction, so everything else stayed the same. So I plugged in and I converted 12 minutes into 60 seconds, and I got 720 seconds. So velocity equals my distance is staying the same at 2,500 meters or 2.5 kilometers, the same thing. All right, 2,500 meters over 720 seconds. And now my direction is north. And when you plug that into a calculator, we get our new answer. All right, she's going a little bit slower of 3.47 meters per second because we have meters and seconds to the north. And that's our answer for part 2 of this problem. All right, the next step is to find her speed, not her velocity, but her speed for the total path. So now with the total path, we know that the distance doubles because it's the whole path. So we have 5 kilometers, or we already know distance is equal to 5,000 meters. And our time this time is going to be the 10 plus 12 minutes, so 600 seconds plus 720. So our time is equal to 1,320 seconds. And remember, we don't need to use our direction with speed. So speed is equal to 5,000 meters divided by 1,320 seconds. Because nothing cancels out as far as units, our answer is going to be in meters per second. And if you take 5,000 divided by 1,320, you get an answer of 3.7 9 meters per second. All right. If you have any questions, please reach out to myself, Mr. Oleg, or Mr. Swenson. Have a great day, everybody.